It's a transportation system unequaled by any other countries in the world. 600,000 bridges, 400 tunnels, 2 million miles of roads. Now, Paving America on Modern Marvels. Arguably, no structures have done more to change the physical and cultural landscape of America than the concrete and asphalt ribbons that make up its vast road network. America's roads traverse waterways, push through mountains, and cross barren deserts. They connect the metropolitan areas to the suburbs, and the suburbs to the farmlands. And they've helped transform a nation once fragmented by rugged terrain into a financial superpower.
Every day you're affected by these paved roads because everything you eat, everything you touch, everything you buy, sell, everything you do, including going to work, is done on those paved roads.
The explosive growth brought on by America's road infrastructure has forced cities across the country to expand on what is already the largest engineered transportation system in the world. These expansions represent the culmination of over 200 years of road building evolution. One of the fastest growing cities in America is Denver, Colorado. Each day, approximately 100,000 drivers make their commute along I-25 from the suburbs, headed for Denver. Just outside the city, I-25 splits off to I-225, which straddles the east side of Denver. A national study in 1999 labeled the I-25 I-225 interchange as the 14th most congested interchange in the country.
This is the corridor that connects the two largest employment centers in the state of Colorado in the Denver region, the Denver Tech Center to the south and the Central Business District to the north.
To alleviate the mounting congestion along Denver's two main arteries, an ambitious $1.7 billion overhaul began in October 2001. It's called the Transportation Expansion Project, or T-REX for short, and its name is fitting for its size and scope. T-REX will pave a total of 17 miles of freeway.
The scope of the T-REX project is huge. On a daily basis, we're doing a little bit over $1 million a day.
The freeway component will add one additional lane in each direction, and 2 lanes along the most congested stretches. The majority of the new lanes will be paved in concrete, which will require millions of tons of aggregate. 20 miles from the paving site is the quarry where the aggregate is mined, sized, cleaned, and then transported to a mixing plant. At the mixing plant, aggregate and the other ingredients needed to make concrete are placed into storage bins. Mixed proportions are controlled by computer and lifted via conveyor belts to a hopper. Cement and fly ash are added to the mix, which then enters a large cylindrical drum mixer, where it becomes concrete.
With tonight's pour, we'll go through about 3,000 tons of aggregate, which this pile behind me will be gone by tomorrow morning.
Approximately 32,000 pounds of concrete are poured into each truck. It'll take 420 truckloads to finish this night's paving. At the paving site, the freshly mixed concrete is dumped onto the roadbed, where it waits to be molded into a 24-foot wide, 9-inch thick, dual-lane highway. This is the task of the slip-form paver, a machine that has revolutionized the concrete paving industry. Costing a cool $1 million, the slip-form paver is the most expensive piece of equipment at a paving site. But its efficiency and multitasking ability make it well worth the price.
So as the concrete's dumped in front of the paver, it runs through a series of augers that auger the concrete to either side of the machine. After that, it goes through a series of vibrators that reconsolidate the concrete into a homogeneous mass.
Sensors located on the paver ensure that the machine is laying down a level and straight road.
The paver runs off 6 sensors. It has 4 sensors that control the vertical grade of the concrete, 2 on each side, as well as 2 steering sensors that keep the paver in line with where we're trying to pave.
Just behind the augers is the paver's screed, which levels the slab. But before it's smoothed, the paver pushes steel dowels into the wet concrete every 20 feet. These dowels provide lateral stability to the roadway. Finally, the paver uses an automated finisher to smooth the slab. In 14 days, the dual-lane road will be ready for commuter traffic. Although this stretch of road is still a work in progress, the completed lanes are already delivering on the promise to ease commuter travel times.
We've seen a significant reduction with the improvements that have been made so far, and when we're completed, we should have significant more reduction in congestion.
The economic and social vitality of American cities, such as Denver, relies heavily on an effective network of roads. This was just as true 200 years ago, when America's first highway, the National Road, was built to connect the eastern United States to territories out west.
Well, the National Road was to get us into the territory. And that, of course, is a very American thing. We want to light out for the territory, as Huck Finn said. We've got to resolve our destiny in all that space, our landscape. And so that's what Americans wanted to do.
With financial backing from Congress, surveyors riding on horseback left Cumberland, Maryland in 1806 and spent the next 4 years marking a 131-mile path that would become the National Road. Today, the old National Road is US 40.
Right behind me is the old path of the National Road as it was built in about 1806. They cut a 20-foot wide path up and down these mountains, a foot deep. And inside of that foot-deep roadbed, they put crushed stones. They would just sit there all day long with a 1-pound round hammer and smash stones and throw them into the hole.
As soon as sections opened, the National Road was flooded with traffic.
You would have seen Conestoga wagons hauling freight from the west back to the markets east. Farmers along the National Road built their homes to raise livestock and crops, and they eventually turned them into hotels. And typical of these establishments, they'd have a barn across the street where they would put the horses and the cattle, and then the men and the women would go across the street, have a nice meal, and go up to bed.
Past Maryland, the National Road moves across western Pennsylvania and into West Virginia. There, the National Road's finest engineering achievement, the Wheeling Suspension Bridge, crosses the Ohio River.
The National Road at that time was so popular, it was called the King of Roads, and this was the King's crown. It was the longest suspension bridge ever built in the world. It was 1,010 feet across, and people didn't understand. It could carry 290 tons. What did that mean? That meant 4,000 soldiers marching across the bridge.
In 1825, the popularity of the National Road led the government to expand it an additional 400 miles west of Wheeling. The second phase of the road was largely surfaced using the macadam system. The macadam roadway consisted of a shallow roadbed 10 inches deep, filled with stones no larger than 2.5 inches wide and 1 inch in diameter. The weight of passing traffic would compact the stones into the ground, making for a hard and relatively water-resistant surface.
The National Road is a shining example of what a hard surface all-weather road could do. And as a result, the other states started building these similar type roads into their hinterlands to expand commerce.
But road building in America was soon curbed by a new invention, the railroad. The invention of the iron horse would curtail road construction in America for the next half-century. The word turnpike comes from the long wooden pole, or pike, that was used to block passage across a road. First used for defense, the pike later allowed for the collection of tolls. Paving America will return on Modern Marvels. We now return to Paving America on Modern Marvels. Over 90% of America's roads are surfaced with asphalt pavement. Asphalt is a viscous compound that comes from the refining of crude oil. To make asphalt pavement, asphalt is mixed with coarse and fine aggregate and heated in a mixing drum. When cooled, it becomes a hard but flexible surface. With so much asphalt pavement covering America's roads, it's imperative that it can withstand the millions of cars, trucks, and SUVs that grind over it each year. At the National Center for Asphalt Technology, or NCAT, in Alabama, 14 different state departments of transportation have their asphalt pavement tortured on a daily basis. But NCAT engineers don't rely on lab tests alone. They put the pedal to the metal along NCAT's 1.7-mile test track.
What we do is full-scale accelerated performance testing. We call it full-scale because we don't use a load simulator. We use live truck traffic to apply the loads, and it's an accelerated test because we apply 10 to 15 years of traffic within a 2-year period of time.
The NCAT truck fleet is able to accelerate road surface wear and tear by carrying twice the legal payload permitted for interstate travel. With 5 trucks on the track nearly 24 hours a day, 5 days a week, that's a lot of miles and a lot of driving in a circle.
I thought I'd go crazy, but it's not that bad. You never get lost. You're never over 1.5 miles from being able to go to the bathroom or take a break. So all in all, it's a pretty good step up from over the road.
The test track is broken up into 45 test sections. 37 sections are being tested for material performance. The other 8 are tested for thickness design.
So if you go out and you build a roadway that's too thin, you're going to have premature failures, and it's going to be very costly to rehabilitate that. If you build it too thick, then you've invested money where you really don't need to invest money.
Onto the surface of the 8 sections are 12 strain gauges, which measure cracking, and 2 pressure gauges that measure rutting. Once per week, data are collected and analyzed.
We call it high-speed data collection because we're able to sample the gauges at a very high rate. 2,000 samples per second is very high. We can capture very precisely what happens as the pavement is loaded and unloaded. A big advantage of this kind of research is that we can quantify mathematically the relationship between pavement response and pavement performance. And once we've quantified that, we have a much more scientific approach to pavement design and pavement analysis.
Today, civil engineers are using tests like this to discover the secret to the perfect road. But in the late 1800s, hard surface roads were practically non-existent since the railroad dominated travel. Shortly after the turn of the century, however, America's love affair with the train was starting to wane.
People were prisoners to the railroads. They were prisoners to when they would be able to depart and when they would be able to arrive. So people were eager to break away from the railroads, but they couldn't because they didn't have the car. Not until Henry Ford invented the Model T and came out with his mass-produced vehicle were people able to truly move about.
The automobile empowered the American consumer. Drivers could go out on their own, when and wherever they wanted, as long as there was a navigable road. Unfortunately, in the early 1900s, there weren't many. In 1901, there were only 650 miles of macadam roads. With citizens demanding paved roads for their motorized vehicles, states started raising money through taxes to build them. Road building at the turn of the century was a primitive and laborious process. Horse-drawn plows and steam shovels were used to clear and grade a right-of-way. Rollers were then brought in to compress the roadbed. From that point on, there was little uniformity. The best roads had sublayers, such as sand or clay. The final surface might be brick, concrete, or rocks coated with a thin layer of asphalt. By 1910, America had a very incomplete patchwork of paved roads. But a group of automobile enthusiasts wanted to change that by building America's first completely hard-surfaced coast-to-coast highway. They formed an association that bore the name of their proposed road, the Lincoln Highway. The proposed Lincoln Highway would start in New York City and pass through 350 cities and 10 states before ending in San Francisco. When the route was announced in 1913, 1.3 million cars were being driven by Americans eager to explore the country.
The Lincoln Highway Association said, if you build it, we'll help you. So get out there, build it, and we'll supply you with the cement so you can make concrete to build the road. But they were really depending on the towns along the way to help build the road.
But construction on the Lincoln Highway would cease in 1917 as the country's focus shifted overseas to World War I.
Cement manufacturing stopped. Asphalt manufacturing stopped. There really was no road building that went on. But it also brought trucks onto the highways in unprecedented numbers to carry goods from the Midwest, places like Ohio, to the port of New York, to take those goods to Europe. And what happened was those trucks just tore up the roads because they didn't have pneumatic tires.
America helped win the war overseas, but at the expense of its roads at home. Yet the final black eye inflicted upon America's system of roads was yet to come. To celebrate America's victory in the war, the U.S. Army organized a highly publicized military convoy to journey across the country along the Lincoln Highway. A nearly forgotten marker in back of the White House commemorates the historical journey.
This is the zero milestone. From this point, all highways were to be measured. It was placed here in 1919. The Secretary of War was here and told them as they left, go by land across the United States by way of the Lincoln Highway.
But it was an arduous trek that took over 2 months to complete. The Lincoln Highway may have existed on paper, but in reality, it was an unfinished and dangerous road.
The Lincoln Highway was as much an imaginary line across the nation as it was concrete and asphalt. There were seedling miles, but they only lasted 1 mile. As a result, the Army convoy found itself foundering in the mud. Trucks and cars turned over, fell into ravines. Some simply had to be left there.
The well-publicized journey brought national attention to the sad state of America's roads. It would take a collective effort by both the federal government and the local states to rebuild America's road infrastructure. In 1903, Dr. H. Nelson Jackson won a $50 bet when he and co-driver Sewell Crocker became the first to cross the U.S. in an automobile. The 2-month trip from San Francisco to New York City cost Jackson an estimated $8,000. Paving America will return on Modern Marvels. We now return to Paving America on Modern Marvels. Although trucks and cars can put a serious hurt on a paved road, they have an accomplice that may be even more hazardous: water. Water transformed the dirt roads of yesteryear into impassable morasses of mud. Today it causes potholes and hydroplaning. But while our ancestors had little choice but to slog through the muck, present-day research is providing civil engineers with preventative know-how. At the University of Texas at Arlington, civil engineers are studying the characteristics of rainfall runoff atop an 80-foot-long and 20-foot-wide concrete road simulator.
The rainfall that you see behind me right now is about 10 inches per hour, and that is a lot of rainfall.
The test road was built to meet the design characteristics typical of most roads. This meant placing the concrete road on top of an articulated platform.
Roadways are slanted in two directions, one from side to side to get the water off very quickly, and then in its length to get it down to a collection point.
The primary goal of the research program is to study how different road surfaces can effectively reduce one of the most dangerous hazards of driving in a rainstorm: hydroplaning.
Hydroplaning is a thin layer of water that gets between the wheel and the road and cannot be moved out effectively. And therefore, when you go to slam on your brakes, you don't have any friction resistance between the tire and the road surface.
One of the test surfaces being researched is a concrete road with horizontal grooving and a rough broomed texture.
Putting those grooves on there helps it move down this side slope to the gutter for collection, and also helps increase the roughness of the road just slightly to help offset that hydroplaning issue and give you better traction.
Upon completion of the research project, the findings will be sent to the Texas Department of Transportation. Today, engineers are looking for ways to fine-tune America's roads. But after World War I, American engineers were starting from scratch. From 1917 to 1919, the heavy trucks needed to transport goods across the country had destroyed America's road infrastructure. Rebuilding them started at the federal level, under the jurisdiction of the government's new chief to the Bureau of Public Roads, Thomas McDonald.
Thomas McDonald was, without question, one of the most powerful men in Washington. And in 1921, McDonald engineered a highway act made by the federal government which put $75 million into the building of highways.
The impact of the act led to over 10,000 miles of roads paved in 1922. More than 3 times the construction of the previous 5 years. Yet, as soon as it became possible for American motorists to drive on a paved road outside the boundaries of their cities, another problem arose: how to get there and back without getting lost. Few maps contained the hundreds of trail and highway names that adorned the American countryside.
In 1926, the federal government said, no more names for these roads. We need a better system, more organized system. So they decided to number the highways, but the idea was to organize it so people could follow a number to any destination they chose, or a series of numbers. And all of a sudden, in 1926, we start seeing black and white shields popping up all over the country, helping travelers get from point A to B.
The numbering system used even numbers for east and west U.S. routes, with the smallest numbers starting in the north and increasing towards the south. North and south routes were given odd numbers, with the lowest numbers starting in the east and increasing to the west. In the 1930s, President Franklin Delano Roosevelt looked to road building to help bring America out of the Great Depression. His New Deal programs, such as the Works Progress Administration, paved 280,000 miles of rural roads by 1938, while at the same time providing jobs for thousands of unemployed Americans. By 1941, America's paved roads reached 600,000 miles. Yet as road building increased in the United States, the lack of uniformity in America's roads led to steep grades and dangerous curves. Over 30,000 Americans died in automobile accidents in 1940 alone. Thomas MacDonald knew that a major overhaul of the nation's road system was needed.
Thomas MacDonald was invited by the Third Reich to come over and take a look at a new highway called the Autobahn. And when he came back from Germany, he and the groups that had gone over to visit this new roadway were mesmerized by limited access, this idea of separating grades, keeping dangerous railroad crossings apart, taking local roads and putting it underneath the route.
The first of America's highways modeled after Germany's Autobahn was the Pennsylvania Turnpike. It was designed as a 4-lane divided freeway with limited access. 1,200-foot-long entrance and exit ramps, and no more than a 3% grade. It took 2 years to plan and prepare the road for paving. In 1939, workers laid the first batch of concrete pavement. Paving continued for 1 year. In October of 1940, America's first superhighway opened to the public.
The first day the turnpike opened up, the toll booths were packed. People were coming from West Virginia to drive on this stretch of road that they had heard about, and people marveled at it. It was a party on the Pennsylvania Turnpike.
But as the United States became involved in the Second World War, the paving of America slowed once again. Yet it was on the front lines in Europe that General Dwight D. Eisenhower learned firsthand the strategic importance of an effective road network.
And he ships off and eventually becomes the supreme commander of the Allied forces, battling Germany along their famed roadway, the Autobahn. Eisenhower and his armies, once on the Autobahn, were able to pursue the Germans deep into Germany, so quickly that the Germans were sabotaging their own highway behind them to try to slow down Eisenhower's advance.
Dwight D. Eisenhower, who had been part of the military convoy in 1919 that slogged its way across the country along the Lincoln Highway, marveled at the design of Germany's Autobahn. In 1952, Eisenhower was elected President of the United States and soon began pushing forth a national system of interstate and defense highways.
Eisenhower was concerned about the loss of life on the highways. Route 66 was known as Bloody 66. These 2-lane highways were incredibly dangerous, and he knew that this interstate system with a divided highway would be the safest route for Americans to travel on.
Eisenhower approved the historic Federal Highway Act of 1956 in June of that year. The act provided federal funds to cover 90% of states' costs to build their portions of the interstate system. Known as Ike's Grand Plan, it would soon revolutionize the social and economic landscape of America. Even the state of Hawaii has interstate highways. All 4 are on the island of Oahu and are strategically positioned to connect the multitude of military bases located there. Paving America will return on Modern Marvels, here on the History Channel. We now return to Paving America on Modern Marvels. There are over 2 million miles of paved roads in America, and each state is responsible for maintaining its portion. For Texas, that adds up to 186,000 miles, a monumental chore. Thankfully, that job has become a lot easier with the help of this.
The vehicle behind me is a Texas Department of Transportation vehicle, and we call it the TMV, which is the TxDOT modular vehicle. Other departments of transportation also have their own vehicles, but none that are as flexible and collect as many types of data as this one vehicle right here.
The TxDOT modular vehicle uses an ultrasonic sensor to analyze pavement rutting, a line scan camera to count pavement cracks, and a texture laser to measure surface friction, all while traveling at highway speeds. By streamlining road survey technology into one unit, civil engineers can now analyze stretches of road faster and more effectively than ever before.
Well, this road right here has lots of distress, and it's quite rough as well. The automated crack system is doing its job and it's picking up this distress. These are the real-time images of what the camera is seeing. Move over to the right a little bit to get some of that lane stripe. Man, this is terrible road. I'm not an engineer, but if this were my opinion, I would say that they need to seal the cracks or do a seal coat.
The data are sent to the department's mainframe computer, where they're analyzed and used to prioritize which state roads are most in need of maintenance. Although maintaining today's highways requires specialized equipment like the TxDOT modular vehicle, back in 1956, an entire industry of earth-moving equipment was launched to move the billions of cubic yards of dirt needed to build America's interstate system.
Eisenhower saw the interstate system as a way to answer the country's most urgent needs. If there was a nuclear attack, it would be the way that the Army would go to ground zero. It would be a way for people to evacuate the city. He saw it as a way of commerce. He knew that this would do a lot for the country commercially.
To establish the acceptable standards and materials for America's new interstate system, the government spent $27 million on a 7-mile test track in Ottawa, Illinois, to test thickness variances of Portland cement concrete and asphalt concrete pavements. In November of 1958, soldiers drove along the highway to nowhere around the clock for 2 straight years.
What it did was it proved what surfaces were the best. So all of a sudden, the federal government is dictating the types of materials that will be used. They all had to now meet federal specifications.
A new numbering system was devised as well to ensure that the U.S. route numbers wouldn't cross with the new interstate numbers. The scheme for numbering the new system of highways was to do the same as the one from the 1920s, but in reverse. Interstate highways running east and west were given even numbers, with the highest numbers starting in the north and decreasing to the south. North and south interstates were assigned odd numbers, with the lowest numbers in the west and increasing to the east. In 1956, construction on Eisenhower's interstate system began, putting in motion the largest earth-moving project in the history of the world. Huge excavators dug a rough path 200 feet wide. Bulldozers stripped the area of its topsoil. Scrapers dug out millions of tons of earth, which were used to create the roadbed. Machines sprayed a thin layer of hot liquid asphalt, which prevented ground and surface water from creeping into the foundation. Finally, trucks poured out the roadway's base and final surface. Either asphalt or a layer of concrete poured around rebar.
The uniformity of the interstate system is its success. The road is no more than a 6% grade out in the mountains, no more than a 5% grade in the city. The interstate system's lanes are 12 feet wide each. There's a 10-foot shoulder on your right, a 3-foot shoulder on your left. The road is straight as possibly can be. And all of that means when you're driving down the road, there's no unpredictability.
From 1956 to 1970, concrete pavement was the preferred material used to surface America's interstate system. But by the 1970s, the concrete that had paved nearly 60% of the interstate was beginning to show signs of wear and tear. Asphalt pavement would complete much of the remaining interstate system, as well as resurfacing portions that were falling apart.
As the infrastructure started aging, you're faced with a decision that you have to make of removing and replacing concrete, which is a very costly and time-consuming thing to do. As those decisions started being made, you see asphalt coming more on the scene.
One of the greatest benefits to using asphalt pavement is that it can be driven on as soon as it's laid, unlike concrete, which takes days to cure. Asphalt has another key benefit as well.
The wonderful thing about asphalt is it is 100% recyclable. Each year we pick up about 65 million tons of asphalt. Of the 65 million tons that we pick up, about 80% of the 65 million tons is recycled back into asphalt pavement.
Asphalt pavement, like concrete, is produced at a mixing plant. Aggregate comes in from a quarry and is dried inside a large mixing drum. From there, the petroleum product, liquid asphalt, enters the mix. Inside the drum, the mixture is heated to approximately 320 degrees. The resulting asphalt paving material is then moved by a conveyor belt to a silo, where it's loaded into trucks that bring it to the paving site. At the paving site, trucks pour the mix into a material transfer device that feeds it into the asphalt paver. The paver's augers spread the mix out evenly. A screed shapes the pavement to its desired thickness. Rollers compress the asphalt mix. Engineers check to make sure it's level. Workers place lane lines. And a new stretch of road is ready for traffic. During the last 50 years of the 20th century, approximately 70% of America's nearly 2.5 million miles of hard surface roads were built. Rural roads were connected to the cities, which in turn connected to the interstate. Half a century after the interstate system project began, the federal funding appropriated by Eisenhower's Grand Plan continues in Boston with the Big Dig, the most complex system of tunnels ever built. The longest transcontinental interstate highway in America is I-90, which stretches a total of 3,087 miles from Seattle, Washington to Boston, Massachusetts. Paving America will return on Modern Marvels, here on the History Channel. We now return to Paving America on Modern Marvels. Although America's interstate system consists of only 2% of the country's total street and highway mileage, it carries over 20% of the nation's traffic. Testament to the efficiency and connectivity of the system. But the only interstate project currently receiving federal funds from Eisenhower's Grand Plan is Boston's multi-billion-dollar Big Dig. It may be the system's finest technological achievement.
The Massachusetts Turnpike Authority built its portion of I-90 actually before There was the Eisenhower plan for the interstate, but it had one flaw. It didn't complete itself. It didn't do that last 2-mile segment to Logan International Airport. So the big dig, part of it was to finish that connection, finish that roadway, finish the Eisenhower system.
Besides the tunnels, Boston's Big Dig also boasts another technological marvel: Intelligent Transportation Systems, or ITS. America's roads are entering the digital age, as the hardware that built the interstate system is now being supplanted with software.
ITS is basically there to help us run the roadway smarter, more efficient, more effectively, to try to reduce the traffic queuing or the backup we often see in major cities.
One of the key ways of preventing freeway congestion is identifying traffic incidents as soon as possible and removing them before they cause severe delays.
Our tunnel system has approximately 225 active cameras at this point in time. We've divided them up with strategic shots so we can take a quick glance at the overall roadway to see if we have a problem. The operators are assigned to a specific roadway. Their objective then is to zero in on that and see if any sort of problem might be coming up on that section of the roadway.
State Police reporting a disabled motor vehicle, lever connected northbound, sir.
If the incident is minor, such as a flat tire or non-fatal accident, an operator will notify an Incident Response Operator, or IRO, to take care of the problem.
1856, disabled motor vehicle, 93 northbound, lever connector.
The incident response operators are placed in strategic locations throughout the Metropolitan Highway System, perched, ready to go. Once we find the problem, we want to get out in 15 minutes. And if you don't have them pre-positioned, the chances of doing that are very, very slim.
In addition to the first responders, the control center also utilizes variable message signs and can broadcast emergency messages directly to commuters traveling through the tunnels.
All the radio, AM and FM radio that go in there is basically brought in artificially. So you're not getting it from your own antenna. We're basically relaying it down there. During an emergency, I can have that shut off and then pump into the tunnel our own transmission saying that we have such and such emergency and give you instructions.
The Big Dig's Operations Control Center is still a work in progress. But one thing appears certain: intelligent transportation systems are here to stay.
An operations center like this is basically starting to use the roadway as smartly as we can, more effectively. That'll be a never-ending quest, and technology will help us bring it to bear.
The completion of Boston's Big Dig marks a total of 42,795 miles of freeway, funded by Eisenhower's Grand Plan of Interstate and Defense Highways. But the expansion of America's interstate system is not solely reliant on federal funds. State taxes and tolls are paying for the next generation of interstate construction. Although Ike's grand plan is still ongoing, its impact was felt soon after it began. By the 1970s, more people lived in the suburbs than in the cities. And just as the National Road gave birth to prosperous enterprises in the late 19th century, the superhighways of the 20th century spurred the development of massive shopping centers, office parks, hotels, and chain restaurants.
What the road system did was it's made it possible for us to get out into the landscape and given us more mobility. America's road system has really changed our economy and the way we live. It's changed our interior lives. We now think in terms of time and space, in terms of minutes. We don't think of it in terms of the distance.
America's roads conquered vast distances and rugged terrain, uniting a nation like no other transportation network in history. But the system itself may be its greatest legacy for generations to come.
The same way we look back at the Romans and the creation of their aqueducts, people 1,000 years from now will look back at our society and see this interstate system that connected this country more than any single piece of infrastructure. We will be known for our highways.